Assalamu alaikum. In this tutorial, the topics we are going to cover are the basic electrical signals that may be AC signal or the DC signals, verification of the Ohm's law, and then basic concept of DMM, and then the basic concept of DC power supply. First of all, we will start from the types of the signals that are used in electrical engineering. The first one, the type that we want to discuss is the AC signals. What kind of the signal is known as or can be represented as AC signal? There are two major properties of the AC signal. The first property that we discuss for the AC signal is that it always changes with respect to time, because whenever you saw a signal that is varying along with the time, that may be considered as AC signal. And its second major property is that it can vary from positive to negative. It means that some of its amplitude can be exist in positive cycle, and maybe some of its amplitude may be in negative cycles. Let's solve this case. In this scenario, we have x-axis, we have a time, and on the y-axis we have amplitude. Whenever we will judge any signal in electrical engineering, we will draw its along amplitude versus time. So we always keep time axis on the x-axis and the amplitude or the voltages along y-axis. This is the AC signal. Why this is considered to be an AC signal? Basically, it will first prove our first property and the second property. Both properties will be covered in this signal. The first one is it is changing, its amplitude is along y-axis, and that is changing with respect to time. As the time continuously increasing, the amplitude of the signal also increasing. And then till the time t/2, this signal is in positive axis, and then we goes from t/2 to t, and then here the value of the signal, AC signal, is -5 volts. Here -5 volts is designated, and here +5 volts are designated. Its second property is also verified that it has positive and negative polarity. Till t/2 it has positive values, and t/2 to t it has negative values in the amplitude. Then we have another type of the signal that is known as the DC signal. So for the DC signal, we have the constant value at all the times. It has no positive or the negative polarity concept in the DC signals. Let's assume the signal that I have drawn here. In the x-axis we have the time, while on the y-axis we have amplitude. And I have drawn the DC signal of 5 volts here. You are seeing that the amplitude of the DC signal always remain the constant, although the time is increasing. And the other property that we have discussed, that it has no positive or negative polarity at the same time, but it can be a positive or negative. Here the +5 volt signal, it is always remain positive 5 volts, and it can never goes from here to here negative and then goes to positive. If we want to draw our signal that is of amplitude -5 volts or -10 volts, then we draw our signal here separately, and that will be considered as -5 or -10 volt signal. Now, in case of AC signals, we also measure the average value, RMS value, and the peak value. Actually, first of all, we will discuss these major types of an AC signal. What is the average, RMS, and the peak value? Average value, what is the average value? Average value means when we sum up positive and the negative side of an AC signal, then its average value will be calculated. And here in this scenario, whenever the AC signal average value is calculated, it always gives us the results of 0, because the same signal is in positive amplitude and the same signal is in negative side of the amplitude. So whenever we will add both signals, then it gives us the amplitude of 0 volts. So what is the peak value? Peak value is actually the maximum value that an AC signal has, and it can also be in negative direction. Here we have the maximum value of 5 volts, and that is can be mentioned by Vp or Vmax, and some books also represent it by Vm. In the same case, whenever we consider in the negative cycle, we have -Vp, -Vmax, and -Vm. So actually, if we consider the half cycle, then it is considered to be Vp, and then if we consider from this point to this point, then it is called as V peak to peak. If we consider the value from 0 axis to positive, and 0 axis to negative, then it is simply known as V peak or V max. Now, what is the RMS value? RMS is as we know, the average value of this signal is 0. Then how is signal driver circuit? So for that, we always use the RMS value concept. RMS value is actually the effective value of an AC signal that you can use for your circuit. The formula for RMS value is V peak divided by under root 2. First, let's assume a scenario that I want to find out the RMS value of this signal, and that is around 5 volt. Then we have to find its RMS, then it will be V5 divided by under root 2. Here I have drawn the RMS value for 1 volt peak, V peak signal. Here maximum value of V peak is 1 volt, and the negative cycle it has a maximum value of minus 1 volt. When I find out the RMS value of this signal, then its value is around 0.7 volt, because 1 divided by under root 2 gives us the value of 0.7 volt. So 0.7 volt value is the actual effective value of this AC signal of complete one cycle that we can use in our circuits. There is no concept of average value, RMS value, or the peak values in DC signal. Here in today's tutorial, we are actually verifying the Ohm's law. For the finding the values of the Ohm's law, we will use the DMM for observing our values for currents and voltages. Always remember that DMM always measure the value in RMS. So today, whenever we will calculate any value, the DMM will gives us the values in RMS. Now we will come to the Ohm's law. What is the Ohm's law? Ohm's law actually states that the voltages applied to any conductor or the current passing through any conductor is directly proportional to the voltages applied to it. So whenever we remove this constant of proportionality, we have the constant of R. R is actually the resistance of that conductor that create the hindrance in the flow of the current. So here we have drawn the basic circuit, and that is we have provided it V in DC supply of 5 volts, or that we can change here by using our DC power supply. Then we have used 1 kilo ohm the basic resistor, and then we have completed our circuit. Now we will draw the circuit on the hardware, and then we will verify our Ohm's law that whether we if we want to change our voltages, our current in this whole circuit is changing or not. We come here. I have put the resistors of around 1.2 kilo ohm here. First of all, I will find out the value of the resistor that I have used here. So when I have put my probes here, then DMM will showing the value of 1.19 kilo ohms. For finding the value of resistance, you always have to put the probe here, and then you have to press this ohms button so that it can show you the value in ohms. Now, next I will provide positive 5 volts or our input signal to this circuit. I have put my positive supply here, and then I will put my negative point here. Now this has completed our path. Positive 5 volts or the positive your input will come here, and the current will flow in this direction, and will complete the path through power supply. Now I will give input to my circuit by using this DC power supply. First of all, I have to put this, you have to check that all the knobs are anti-clockwise. Now, first of all, if I want to use this voltage or the current scenario, then I have to change it from constant current to constant voltage. Whenever it goes from constant current to constant voltage, then here you will see that green LED will turn on. Now I am able to change my input voltages that you are seeing here. If I put it here in constant current, then if I want to change my voltage probe, then it will not change your input value. So first of all, I have to put it here, and then I will put the input power supply of 1 volt here. First of all, I will measure here that whether the 1 volt is coming to my input signal is here or not. Now I will check. I have provided the input of 1 volt, and that DMM will also showing the value of 1 volt VDC here. Now I will find out the current. For finding the current, I have to break the circuit. It means the path of the circuit will becomes broke. Now you have seen that there is no proper path of the circuit for the flow of the current. Now I will put my probes here to find the current. I have to remove this probe from voltage probe to current probe, and then it is here showing you the value of VDC. First of all, I have to change this to DC current. I will press the shift button, and then I will have to press this, and the current flowing through our circuit is around 0.822 milliampere, and this is the DC input, so your current flowing through the circuit is DC. Now I will increase my value from here to 2 volts. As I have increased double the value of the input, your current also becomes double, around 1.55 milliampere DC. In the same scenario, I will increase my voltages to 3 volt. Here you have seen the value of the current that is increasing proportionally with respect to your voltages, and that is the value of 2.55 milliampere DC. I will increase it here to 4 volts, and here the current is also increased to 3.33, and my last reading will be the 5 volts. Here 5.1, and whenever I have put my values of the 5 volts here, then I have get the value of 4.2 milliampere DC value of your current. Now, why we have get the values at different input voltages? Actually, whenever you have to draw on the graph of current with respect to voltages, then we must have to require different values of currents by applying different values of the input. Here I have drawn the graph that you have seen. At 1 volt, 2 volt input, 3 volt input, 4 volt, and the 5 volts, these are the input values of voltages, and here the current readings that I have get from DMM. First of all, at 1 volt, I have get the values of around 0.88 milliampere that you have recently shown, I've shown you on DMM. And then at the 2 volts, I have get the values around 1.8 or 1.9. And this, at all values, I have just put the points and then draw the curve. And it is this curve is showing that your current is directly proportional to the voltages that you have applied to your circuit. Now we will use a different circuit for finding the values of voltages and the currents. Here I have used the R1, that is same as in the previous circuit. Now I have used another circuit resistors for our circuit. Now our circuit is comprised of the 3 resistors. Now we will find out the branch currents, the main current flowing through this path, and then the current flowing through here, and then some value of the current will be also flowing through I3. I1 is actually the combination of I2 plus I3, because the current coming from the here will be divided into the both branches. For that purpose, I have to change my circuit somehow. And then we will provide our negative value of our voltages here. Here your circuit is completely designed as I have shown you on the page. The voltages value will come here, and the currents will flow start from this resistor to these both resistors. Some will of the current will flow from this resistor, and while the other remaining current will flow from this resistor, and then the current path will be completed through the supply. Now, first of all, I will check the value of I1 that is flowing through the main circuit. I have broke the path of the circuit. I also will put it here, and then I will find out the values around here. And let's suppose I keep my input at voltages at the 5 volts. What will give the value of the current? Whenever I put it the value of 5 volts here of the input voltages, then my output voltage that is 2.2 milliampere. This is actually the I1 that is passing through the whole circuit. Now, whenever you have to find out the current, I have broke the circuit, and then for finding out the current in the other branches, you have to put the resistor in the backward position. Now I will put it on here. And find out the value here. Now I am finding here the value of the I2. The value of the I2 that is passing current passing through R2 is 0.86 milliampere DC. As you have seen, I have not changed my input. That is 5 volts. Now I will place it in backward position. Now I will break the path for the R3. Now I put my. Always try to put the red probe along the positive side of the battery and the black probe on the negative side of the battery. And here you have seen the value of input value was 5 volts, and the current flowing through our R3 is 1.3 milliampere. By this experiment, what we have concluded so far, we have finalized that the current flowing in our circuit is directly proportional to the voltages that you have provided to your circuit. If we increase our voltages, the current also increases. And also we have checked that the current passing through the R1, that is actually the main current that we have designated by I1. It was equal to I2 plus I3. Actually, the current flowing through I1 was 2.2 milliamps, and then the current passing through R2 was 0.8, and the current passing through the R3 was 1.3. So whenever I will sum up 1.3 plus 0.8 milliampere, then it will be around 2.2 milliamps value. This was the whole tutorial for the Ohm's law. Good luck, Hafiz.